So we're going to keep on keeping on within these questions. A certain culture of bacteria, given suitable conditions, triples every 25 hours. The initial count of a sample shows 1,000 present. So if we want to first write the exponential function, I'm going to get a equals. Now we see that we start with 1,000, so I put in that 1,000, and then it triples every 25 hours. So that means we're going to have the 3 in there. Since it's every 25 hours, I'm going to keep t in terms of hours, and I'm going to put this over 25. Approximately how many bacteria will there be in 4 days? So 4 days, we want to multiply that by 24, and that gives me that it's going to be after 100 hours. So I get A equals 1,000 all multiplied by 3 to the power 100 all over 25. And quickly punching this into our calculators, we get that my A is going to equal 81,000 bacteria. So I'm just going to put this in words. There will be 81,000 bacteria. How many bacteria were there 3 days prior to this count? So we actually don't need to overthink this. I again can just go 3 multiplied by 24, and 3 multiplied by 24 gives me 72. Now, since we're going 3 days prior to that count, I can now go A equals 1,000 multiplied by 3 to the power negative 72, because we have negative 72 hours now, and then that's all over the 25. I go 1,000 multiplied by 3 to the power negative 72 divided by 25, and this will give me approximately 42 bacteria. Now again, when we're looking at this, we always try to round up the number when we can't split something. So there was approximately 42 bacteria. Moving on, a country's population is growing at a rate of 3% annually. Assume the population is now 30 million. Now for this one, I'm going to keep it in terms of millions to make sure the numbers don't become too unwieldy. Write an exponential function that relates the population p at t to the time in years from now. So again, checking this out, I'm just going to label this as being p at t because we're talking about populations. My starting population is 30 million, and it's going up by a rate of 3% annually. Now, this 3%, what does that mean? That means we're adding 3% to the value each time. If you want to go to a store and you want to buy something, let's say, and I'm just going to do a little side right here, but let's say that you want to buy a shirt that's $100. Well, we know that we have a 5% GST on that. So one way of handling that is to multiply it by the 0.05, then saying that's $5 and going, well, then 100 plus 5. But a faster way would be multiplying it by 1.05. What does that 1 do? That 1 maintains the original $100. So if I break this out a bit more, it would be 1 plus 0.05. So what's happening is my 100 multiplies by that 1, and that gives me the initial value of the $100. Then I multiply that 100 by 0.05, add them, and that gives me the $5 that I'm going to add. The same thing kind of goes on here when we're looking at this question. It's growing at a rate of 3% annually. So that 1 is going to maintain the rate, or it's going to maintain that original 30. Then 3% is given as 0.03. So the 1 maintains the original value, and the 0.03 is what I'm adding to it. We also see that it's annually, so that means that's going to happen every year. That means that I can just keep my time as being t. So what we get right here is we get p at t equals 30, 1.03 all to the power t. What will the population be in 15 years? So in 15 years, we just go p at t equals 30 multiplied by 1.03 all to the power 15. 30 multiplied by 1.03 to the power 15 just gives me 46.739. And I carried quite a few digits right there. But we'll just round this up and we'll say, well, that's approximately 47 million people. Now I rounded this quite a bit, but I also do have my original answer sitting right there. Approximately how many years will it take for the population to double? So for my population to double, well, that means that I want to double 30. So that means it's going to be 60, and that will equal 30 multiplied by 1.03 all to the power t. Now this again is going to be a case where I go y1 and y2. So I go y1 equals 60 and y2 would equal 30 times 1.03 to the power t. Now one thing that I do want to bring up about looking at this is some people may say, well, could you multiply, or rather divide, could you divide the 30 by both sides and get the 2 on the other side? And the answer to that is absolutely you could. I'm just not doing this. I'm avoiding a lot of the algebra that you do in the pre-steps to this. But if that's the way that you wanted to do it, that is perfectly fine, and you can do that. So we punch this into our calculator. Again, we get that kind of picture that they'll all look like, where you have the graph that goes up, and I know that's a terrible drawing of the picture, but we're looking for that intersection right there. If you have to change the window value, go for it to find out what the answer is, but then we go second, trace, intersect, and we get that the answer is approximately t will equal 23.44, 450, or we're going to say, well, after approximately 23.45 years. So after 23.45 years, the pop will double. Okay guys, I hope you enjoyed. Until next time.